Welcome to the second part of the video dealing with permutations and combinations. That is, utilizing permutations and combinations in a case where we are dealing with doubles tennis matches. And this particular video will be dealing with three scenarios, three interesting situations. One, a case of forming teams without any restrictions. The second case of married couples. Interesting situations dealing with married couples, and the third case will be generating a general formula where there are 2 raised to n players. And so let's look at the first case. Suppose there are a group of 10 players. Basically that means there will be 5 teams of 2 players each. And how many ways can these teams be got? That's what we are looking at in the first case. So how many different ways can this group of 10 players be divided into 5 teams of 2 players each? First, let's look at how to get the answer in a logical manner and understand that thinking a mathematical thought process, getting the right mathematical thought process is very important in this particular section dealing with permutations and combinations. And as for the first 10 players, for the first round, we can easily see that there are 9 ways in which the pairs can be selected. That is 1 with 2, 1 with 3, going on to 1 with 10. So basically 9 ways of selecting a pair. Going on to the second round, naturally there will be 8 players, which means that 8 minus 1, 7 ways of getting a pair there. So second round, 7 ways of getting a pair. Going on to the going on to the third round, where there will be, of course, 6 players. So basically 5 ways of getting a pair. That is 5 with 6, 5 with 7, something like that. So 7 ways of 5 ways of getting a pair. So interestingly, a very solid pattern is emerging. That is first round, 9 pairs. Going on to the 5th round, there's 1 pair, and that pair, of course, is the winning pair. So the answer would be 9 times 7 times 5 times 3, which of course would be 945 different ways of getting a pair. Now we are looking at the theoretical process. So in the first round there are 10 players, which means that selecting a pair from those 10 players is of course 10c2. Going on to the 5th, which would be 5th, which is the last round, that is 2c2, and then multiplying all the possible combinations, that is 10c2 times 8c2 times 6c2 times 4c2 times 2c2. That's 10c2, 8c2. So now the interesting thing is that understand that the order of selection, order of getting the selecting a team is not important, which means that we have to divide the whole result by 5 factorial, and that would give 945. The third method, which is a direct method, we already have a formula which is a derived formula, which we can apply to get the result without any further hassles. So number of ways in which mn different items can be divided into m groups, each having n objects, where order of the groups is not important, is given by nm factorial by n factorial raised to m times m factorial. And in this particular case, that would be 10 factorial by 2 factorial raised to 5 times 5 factorial, and we'll be again getting 945 different ways of getting a team. Now going on to a very interesting usually asked question in this particular doubles matches, where here we have 4 couples, that is 8 players, and the first problem is dealing with how many games can be played if a married couple is not there in a match. Understand that it basically means that a married couple shouldn't be there in a match, which means that out of the 4 players there shouldn't be a married couple. That's the meaning of it. So now in a game of 4 players, there should there shouldn't be a married couple. That's the meaning of this question. So how can we get the answer? So selecting a particular pair out of 4 teams is 4C2. The second team can be chosen in 2C2 manner, and of course the women players can be arranged in ways, that is 2 factorial, which means that the answer would be 4C2 times 2C2 times 2 factorial, which would be 12. So there are 12 games where a particular game doesn't have a married couple. Now let's bring more something like a twist into this problem. What if instead of not having a married couple in a particular game, what if there's in a team itself there's no married couple? So understand the difference here. In a team, there is no married couple. So it's not in a game itself; it's in a team itself. So the difference should be clear. The team shouldn't be comprising of a married couple. So let's get the answer first in a logical and very interesting manner. So the first 2 teams out of 4 can be selected in the 6. It is 4C2 6 ways, which means that the maximum games will be a multiple of 6. And going on, out of this 8 players, if we are choosing the first pair, that is husband 1 and husband 2, there's a single possibility of getting the pair with first wife and second wife, following the condition, and going on again with the first husband and second husband with the other women players. There are 3 possibilities. Similarly, with the third husband and the fourth husband, once again there are 3 possibilities, and finally there's a single possibilities where the husbands are shuffled and something like H1 H3 or H2 H4. So total there is 3 plus 3 plus 1, that is 6 plus 1, that is 7 possibilities, and multiplying that with 6, that is 4C2 times 7. So here 7 times 6, so there will be 42 games where the husband-wife doesn't form a team. Now understand, this means that a team wouldn't be having a husband. What if we are looking at a case where at least one married couple will be playing a game? So at least one, which basically means a team would be comprising of, out of all the teams, one team will be having a married couple. So selecting one married couple out of 4, basically that is 4C1, that is 4 itself. Now we can see that out of this 8 players, one male for the other teams can be selected in 3 ways, and you can get a non-couple female afterwards in 2 ways. So because after a male is selected in 3 ways, only 2 ways are left to select a female, which is a non-married player. So total would be 4 times 3 times. So the total games where at least one team is a married couple, it would be 24. Now what if here means one married couple is there. What if we are looking at a game where there's at least one married couple? So 24 games means one married couple is present. What if there's a chance of at least one married couple? That would be 24 plus 6, that is 30. So surely one married couple, that is 24 games. At least one married couple forming a team, that is 30 games. Going on the third section, we are looking at generating a general formula in a knockout tournament, which basically means that the failed players won't go to the next round. So the number of competitors is 2 raised to n. Naturally, the number of rounds is n. And here, there are no playoffs for positions 2, 3, going all the way up to 2 raised to n minus 1. And the initial tables are drawn. So these are the conditions. So for 2n players, naturally the number of games in the first round will be 2n by 2, that is 2 raised to n minus 1 games. And the number of games in the second round would be 2 raised to n minus 2. And the combination of the winners would be in the second round 2 raised to 2n minus 2. And so the summation would be sigma I to n, where I is equal to 1, and 2 raised to 2n minus 1. That is 2 raised to n minus 1 total possible winning combinations. Of course, we shouldn't forget that in the end there will be only 2 players. That's a team. It's a team that is 2 players will be winning. So thanks for watching this video.